This session is for OCR FP2. We're looking at question 4 from January 2010, and that is on polar coordinates. So if we have a quick look at what the question's asking us to do, so we've got an equation of a curve in polar coordinate form, r equals e to the minus 2 theta, for theta between 0 and pi. In part 1, we're asked to sketch the curve, stating the polar coordinates of the point at which r takes its greatest value. And then in part 2, the pole is O, and P and Q with polar coordinates r1 theta 1 and r2 theta 2 respectively lie on the curve. Given that theta 2 is greater than theta 1, show that the area of the region enclosed by the curve and the lines OP and OQ can be expressed as k upon r1 squared minus r2 squared, where k is a constant to be found. So we've got, first of all, to sketch the graph. Now, as I say, you may feel that you can sketch the graph without this, but don't be afraid to start at least doing a few values in our table to see what's happening. So if theta is equal to 0, then r is equal to 1. And then if I take quite small, and we'll go up in sections of pi over 12, when theta is pi over 12, then r turns out to be about 0.6. Pi over 6, it turns out to be 0.4. Now I'm giving these answers just to one decimal place because, of course, we're only going to be doing a sketch of the graph. So if we do pi over 4, then it's 0.2, and pi over 3 is 0.1, and then pi over 6, by the time we get to pi over 6, it's actually about 0.04, and from the question it says that we've got to sketch it from 0 to pi. By the time we get to pi, then it's very small indeed. In fact, 10 to the power of negative 3. So the important thing is, the first thing it says, stating the polar coordinates of the point at which r takes its greatest value. So r equals 1 when theta equals 0 is going to be the greatest value. And if we come and try and sketch the graph here, so this is 1 and this is the pole, then as we increase the angle, then we are decreasing the value of r, and it actually comes down like this. And when theta is pi, this is very, very small indeed. Right? And notice, of course, that it doesn't go through the pole 0, because, of course, you can't have anything to the power of 0 being equal to nothing. So just 2 marks for that, and basically really there was just 1 mark for stating this was the maximum value, and 1 mark, and it was actually a B mark, not a method mark, and a B mark here just for a sketch. So in part 2, we're then asked to do some integration because we want to find the area. So we need to remember that if polar graphs, the area is given by a half r squared d theta. And we're told that theta 1 is smaller, so it'll be between theta 1 and theta 2. So r is equal to e to the minus 2 theta. So r squared will be equal to e to the minus 4 theta. So if we put that in here, so effectively what we've got to do is we've got to integrate e to the minus 4 theta d theta and evaluate between theta 1 and theta 2. So when we integrate e to the minus 4 theta, we're going to get minus, well, we have a half there, and we're going to divide by a 4, so we'll end up with 1/8 minus 1/8 e to the minus 4 theta, and we'll be evaluating that, as I say, between theta 1 and theta 2. So substituting that in, we end up with minus 1/8 of theta e to the minus 4 theta 2 minus e to the minus 4 theta 1. Now if I just take that minus sign and bring that inside, then what we'll end up with is 1/8 of e to the minus 4 theta 1 minus e to the minus 4 theta 2, which of course is 1/8. And again, we can just check it from up there, so that's going to be r1 squared minus r2 squared. And the question said to show that it could be expressed as a multiple of r1 squared minus r2 squared, where k is a constant to be found. So we've done that, and our constant, of course, k is equal to 1/8. So there were 5 marks for that question, and if we just have a quick look at how the marks are actually awarded, you got a method mark here for seeing that it was e, you were integrating e to the minus 4 theta, a half of that, an accuracy mark for doing the integration correctly, a method mark for substituting in your limits, and a method mark for showing then that that was 1/8 of r1 squared minus r2 squared here, and then an accuracy mark at the end just for stating the value of k. So 5 marks for that part, 2 marks for the first part, so 7 marks in total for that question. So don't forget that if you want to access further revision videos, then you can do so by going to the Further Maths website and following the link.